When using t, the measure of effect size is very similar to what we had before. You'll remember before we had the population standard deviation in the denominator. So in this case, we just have the sample standard deviation. Piece of cake. So let's apply one of those. For example, in a research example, in the infant face study that we just talked about, adorable babies averaged 13 seconds out of 20 looking at the attractive face. If there was no preference, the population mean would be 10 seconds. Thus, the results show a 3-second difference between the obtained mean and the hypothesized mean if there's no difference. So we already went through this stuff where we determined the standard deviation was 3. And therefore, if I plug that into Cohen's, it's 13 minus 10 over 3. And I got an effect size of 1. Okay. Well, and by the way, where does that fit? That would be a large effect. A mean difference of about 0.8 standard deviations or more. So this would suggest this was a fairly large effect for having the attractive face. And by the way, we're comfortable using the phrase effect size because this truly was an independent variable. We actually manipulated the nature of the face. By the way, if you'll just indulge me for a minute, Jacob Cohen lived recently. I believe he died in 1998, although there was a weird situation where no one knew it. It was really sad. As influential as he was, he died in 1998, and his obituary wasn't printed in American Psychologist until 2001, which is a sad irony given his influence. But if we were taking these classes 30 years ago, it's an open question of whether or not we'd even be talking about Cohen's d. He really revolutionized inferential statistics insofar that he insisted that we report this other piece of information. Because you'll remember from chapter 8, is it possible to have statistical significance and reject the null hypothesis if you don't have a large effect size? And the answer is yes. Well, how could that be? How could we have statistical significance and reject the null hypothesis if we don't have a large effect size? And the quick answer is a large sample size. You could have a very tepid effect, a very small practical effect, as Cohen's d measures, and have a gigantic sample size and still render statistical significance. But one could argue that the practical effect is the true outcome or the true indicant of whether what you did is significant. In this case, you see the formula could not be more direct. Just like the hypothesis problem, m minus mu in the numerator and the standard deviation in the denominator. And in this case, we happen to get a large effect size. And again, here are some of the guidelines that have been adopted almost posthumously without Cohen's permission, really. He thought this was a bastardization of what he wanted. But nonetheless, these are the prevailing guidelines on how to evaluate a Cohen's d effect. And in this case, that'd be large. We had a 1, and of course, large begins at 0.8 by these conventions.